A while ago, I created SPIR and torus on my computer monitor. It might look very challenging at first sight, but once you succeed in computing the vertices of these torus and SPIR, the OpenGL library renders your SPIR and torus. Hi everyone, my name is Thomas Kim. Today is September 15th, 2022. This is my 55th episode for C++ 17 2023 CUDA SQL OpenGL OpenCL TBB. We will set up OpenGL CUDA 1. More specifically, we will install GLUT, freeGLUT, GLFW, GLEW. Please note that GLUT is older library, no more maintained. Pre-GLUT is good enough, but we still need the older library GLUT for compatibility with the existing source code. We will also install GLFW, GLEW. We will be using OpenGL Programming Guide. Please double-click this link. We will use OpenGL Programming Guide, the official guide to learning OpenGL version 4.5 with SPIR-V. This will be our main textbook for OpenGL programming. We will be also using OpenGL Superbible, this link. We will also use OpenGL Superbible Comprehensive Tutorial and Reference 7th edition. We will use some CUDA books, Professional CUDA C Programming, this link. This book is written in 2014, but this is still a very good book for learning CUDA programming. For beginners to CUDA programming, I would suggest this book, CUDA by example. This book was written in 2010, but this book gives general idea about CUDA toolkit. I would also use CUDA for engineers, this book. This book is also very good for integration with CUDA and OpenGL. If you need 3D graphics as well as CUDA programming on your application, I would highly recommend you this book, this book, this book, this book. I will post this script in the description section below this video. Just so you know, if you want to use CUDA toolkit, you need CUDA device. If you scroll down in this table, compute capability, I'm currently using RTX 2060. RTX 2060 is Turing architecture. It supports compute capability 7.5. I would highly recommend you to have CUDA compute capability version 8.6 or above, such as RTX 3060 or above, because if you want to use more advanced latest feature such as Tensor Core, then you probably need at least computer capability version 7.0. But version 7.0 is very primitive. I would advise you have CUDA device at least version 7.2 or above. My CUDA device compute capability version 7.5 is a minimum version that supports Tensor Core. Tensor Core significantly improves matrix computation. The reason I recommend version 8.6 is that beginning 8.0 or 8.6 floating point 64, it means double precision floating points operations are supported. In case of version 7.5, FP tensor core means floating point or float precision for tensor core with compute capability 8.6. Double precision floating point operations are supported in the tensor core. That's why I recommend compute capability version 8.6 or above. We will download and build 4 tools. As I said previously, GLUT is no longer supported, but some source code or sample code from the books I mentioned above uses GLUT. For such reason, we will download GLUT library. This library is no longer supported. We will download pre-built library. Obtaining the GLUT precompiled installable image for Microsoft Windows. If you want just GLUT header file and LIB and DLL all precompiled for Intel platform, you can simply download. So please double-click this link. The reason I will not build GLUT library is that this library is no longer supported. So building GLUT for Microsoft Windows does not make sense. Now we will download freeGLUT from this link. We will click this button and download. In case of freeGLUT, this is still maintained, so we will build by ourselves. GLFW. Please double-click this link. From this website, double-click latest version. We will also download GLEW. Please double-click this link. We can install Windows binary, but I will build with source code by ourselves. Please double-click this link. It will download. We basically downloaded 4 zip files. We will start with this one. Unzip it. Double-click it. We need these libraries. I will rename GLUT 3.7. I will open another file explorer and arrange side by side. From C drive, DEB soft, we will create a new folder, GL tools. Here we will copy and paste it. You should find DLL header file LIB. Now we will unzip. freeGLUT. In this folder, we will unzip freeGLUT 3.2.2. You will have some error message. You can ignore this. Close. In this folder, you can find the source code. Now, copy this, paste it in this folder. Go up. We will unzip GLEW. Unzip it. So this is GLEW 2.1. You can find the source code. Now copy this, paste it here. Go up. We will unzip GLFW. GLFW 3.3.8. Unzip it. In the folder GLFW, you can find the source code. Now copy, paste it here. Don't delete these files yet. If we fail to build, then we have to copy and paste it here again. We start with freeGLUT. Please double-click this folder. Copy the folder path. Open up your Microsoft C++ compiler. This is for 64-bit compiler. CD, paste, hit enter. We have to change our drive. CLS, dir. We should be in C. DBsoft GL Tools, freeGLUT 3.2.2. Please understand that I installed latest version of Microsoft compiler, Microsoft Visual Studio 2022, CLS, dir. We need CMake, then C make list .txt, hit enter. Looking for systypes H. Systypes H found. Unist.h. Unist.h not found. You don't need to concern about not found. These are Unix files, so don't concern about not found. But dir sln, you should find solution file. In this folder, you should find freeGLUT solution. Now open up Visual Studio 2022. Once again, I'm using latest version of Microsoft compiler, Visual Studio Community Edition 2022 64-bit version 17.3.4. From File, Open Project Solution. From your Explorer, copy the folder path, paste it here, hit enter. Then you can find freeGLUT sln solution file. Open. From this, we don't need to build all. All we need is freeGLUT. We start x64 debug build. Right click, project only, build. We have some warning messages, but we can safely ignore these warnings. You should see one succeeded. In the File Explorer, in the bin folder, debug, these are built. Also, include GL, these files are generated. Also, lib debug. These files are generated. These are debug build. Now, in the Visual Studio again, we will change to release build. Right click, project only, rebuild only freeGLUT. You should see rebuild all one succeed. Once again, here bin release. This DLL is for release build. Go up, lib release. These are for lib release build. Also include GL. These are the same header file. Up to this point, we built GL tools, freeGLUT. I will explain in future session how to make environment variables for freeGLUT. Now we will build GLFW. Please double click this folder. Copy the folder path. In the Microsoft command prompt again, cd paste. Hit enter. We are now in GLFW folder. cls dir. I will post this script in the description section below this video. Please double click this link. In this web page, documentation tab, please double click documentation. HTML documentation, please double click this link. Once you have written a program, C compiling GLFW, please double click this link. From this document, please scroll down until you find Show the CMake option. If we want to build shared libraries, we need this command line switch. So copy this, copy in your Microsoft compiler, paste. We will remove this part like this. Now hit enter. Don't concern, pthread not found. dir, you should be able to find GLFW solution. Copy this folder path again, because we have solution file here. In the Visual Studio, once again, close solution, open project solution, paste. Select GLFW solution, open. We will start x64 debug build. Right click, we can just build solution. You should build 33 succeeded, no fail, 0 up to date. You should see 33 succeeded. Now x64 release, we build a solution. You should see 33 succeeded. In the File Explorer, once again, you can find src, debug. These are for debug build. Release. These are for release build. In the source again, in this folder, in the include folder, GLFW, you should see the header file. So we built GLFW. I will explain how to set environment variables for this library in near future sessions. Now we will build GLEW. Please double-click it. In this folder, you can find build BC12, copy, paste. Change it to BC143. Double-click this folder, copy, open up your Visual Studio, close solution, file, open, project solution, paste the folder path, open up GLEW solution, select latest installed version, select upgrade to 143, click OK. Now select x86, debug. We will build GLEW shared library, project only, build only GLEW shared. You should be able to build successfully. Now release. We will build project only GL shared. You should build successfully. But we have link warning. Undesirable base address x62AAA for x64 image. Instead of doing this, right-click, go to Properties, select All Configuration, All Platform, Linker, Advanced, Base Address, select Inherit from Parents or Project Defaults. Click Apply, click OK. Now we rebuild. Project only, rebuild only GLEW shared. Now you should see no warning. We just built release build. Don't forget debug build too. Rebuild project. You should successfully build. Now we can exit. We built GLEW. In the bin folder, you can find debug build. Also, release build. We are not interested in 32-bit build. You should be able to find lib, debug. Also, release. In this episode, we built pre-GLUT, GLEW, GLFW. I will explain in future sessions how to make environment variables for this library and how to integrate OpenGL with CUDA.